All right, before we get started, well, first of all, we're going to continue with the quadratic formula. And we're specifically going to look at solutions that have radicals in our answer. So in the previous lesson, everything simplified really nicely. You got two answers. They were whole numbers, they were fractions. But here we're going to look at answers that have, or solutions that have radicals in our answer. But before we do that, I do want to look at a couple problems and talk about how we simplify things, which I think will make the process a little bit easier. So let's just start with simplify the expression. And we're going to simplify 6 plus or minus the square root of 180 over 6. Okay, 6 plus or minus the square root of 180 over 6. So just like we have been doing all year long, anytime you see a radical, you need to see if you can simplify it. Now, everyone's teacher does it a little different. I'm going to use a factor tree. Some of you use a ladder method. You do what works best for you. But if we do a factor tree, okay, I'm looking for two numbers that multiply to 180. So I can do 18 and 10. And then that breaks down to 9 and 2. 10 breaks down to 2 and 5. 9 breaks down to 3 and 3. And that's going to be the only thing that breaks down. Remember, you are circling your pairs. So I have a pair of 3s. And I have a pair of 2s. And I have a leftover 5. So the pairs come out. The leftovers stay inside. Okay, so that gives me 6 plus or minus. My pairs come out. 2 times 3 is 6. My 5 stays inside, all over 6. Okay, so I have to simplify the radical first. At that point, you're going to check all 3 outside terms. If all 3 of those outside terms can be simplified by a number, you have to do that final step of simplification. So all 3 outside terms in this case are the 6, a 6, and another 6. So I can divide every single term by 6. 6 goes into itself once. 6 goes into itself once. 6 goes into itself once, leaving me with 1. Okay, I have to leave that 1 there, plus or minus. Now this 1 I can get rid of. I don't need it because I have the radical. So you can do 1 square root of 5 or just the square root of 5. And then this 1, again, you can leave it if you want, but you don't need to. So this is an acceptable answer. I would, however, write it as 1 plus or minus the square root of 5. So this would be my final answer if I were to solve the quadratic formula and get something like this above. Okay, let's try another one like that. Let's try 12 plus or minus the square root of 200 over 10. Okay. So again, first things first is you always try to simplify that radical. So 2 numbers that multiply to 200 would be 2 and 100. Right, you have a couple options. You can do 20 and 10. And then 100 breaks down to 10 and 10. And I can stop right there because I have a pair. That 2 is not going to pair with anything, so that's going to be what's left over. So that leaves me with 12 plus or minus. The 10 is the pair, so that comes out with the 2 left over inside all over 10. And again, you're looking at the 3 outside numbers to see if anything goes into all 3 of them. So 12, 10, and 10. The number that goes into all of them is 2. That's what I can simplify by. So 2 goes into 12 6 times. 2 goes into 10 5 times. 2 goes into 10 5 times. Okay. There's nothing else I can simplify. You cannot simplify here because that 5 doesn't go into the 6. Okay, you have to look at all 3 outside numbers. So final answer is going to be 6 plus or minus 5 square root of 2 all over 5. Okay. Let's look at 2 plus or minus 4 square root of 7 over 6. Okay, so first things first, can I simplify the square root of 7? Okay, 7 breaks down to 7 times 1, so it doesn't simplify anymore. So from here, I'm looking at all 3 outside numbers and finding a number that goes into all of them. That's divisible, that divides into all 3 of those numbers. So 2, 4, and 6, the number that goes into all 3 numbers is 2. 2 goes into itself once. 2 goes into 4 2 times. 2 goes into 6 3 times. So my answer here is going to be 1 plus or minus 2 square root of 7 all over 3. Okay. All right, last one before we do some quadratic formula. Let's look at 4 plus or minus the square root of 10 all over 6. Okay, so first of all, let's look at 10. Can I break down 10? 10 breaks down to 2 and 5. Okay, there are no pairs, which means everything goes back inside. So I'm left with kind of what I started with, right? Now, in all 3 of these problems, we had to look at the 3 outside numbers. So my 3 outside numbers are 4, 1, and 6. Okay, so I'm looking at the 4, the 1, and the 6. Is there a number that you can divide into 4, 1, and 6 to simplify? Hopefully you're answering no. Okay, there's nothing that you can simplify, divide into 1 that would simplify it. That also goes into 4 and 6. Obviously 1 is as simplified as it can get. So your final answer here is exactly what we started with. 4 plus or minus the square root of 10 over 6. There is nothing else you can do with that problem. Okay, so that's going to be the biggest thing as we work through the quadratic formula, is making sure you understand how and when you can simplify. So it's been a week, right? We were on spring break. Let's recap what the quadratic formula is. So quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. All right, we are going to use the quadratic formula to solve. Now, after this coming week, we're going to do choose your method. The quadratic formula, like we talked about last week, will always work. You will always get a solution. with the quadratic formula, but some of you have mentioned that it's a long process, that it's too much work. So maybe that's not the method you choose, but know that if nothing else works or you don't remember how to do the other methods, the quadratic formula will always work for you. So let's actually solve. How about we look at 11x squared plus 4x minus 16 equals 0. Okay. First thing we want to remember as we go through these is that it has to be in standard form. And again, I can recap standard form. So standard form for a quadratic equation is ax squared plus bx plus c. Now you could be missing those terms or a term, and if you're missing a term, that means your value there is just 0, and that's okay, but you want to make sure you have your x squared term, your linear term, your single variable term, and then your constant. And in this case I do. So I'm going to go through and identify a, b, and c. A is 11, B is 4, C is negative 16. Okay. We're going to take our A, B, and C and we're going to plug it into the quadratic formula. So x equals negative B, and I'm going to put my B in parentheses this time, because I know some of you were confused with this negative, which is attached to the formula. You have to keep the negative, and then if this b term is also negative, it becomes a positive. So maybe this will help. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. My square root should go all the way across. Okay, one step at a time. All right, so x equals, this negative and the 4 just becomes a negative 4, plus or minus the square root. So we're going to simplify here. 4 squared is 16. Negative 4 times 11 is negative 44. And negative 44 times negative 16 is a positive 704. Okay, so negative 4 times 11 is negative 44. Negative 44 times negative 16 is a positive 704. All over 22. Okay. X equals negative 4 plus or minus, well, 704 plus that 16 gives me the square root of 720 all over 22. Now the first thing I would check to see is if this is a perfect square, because if it is, it makes my life easy, right? So the square root of 720 is going to give me a decimal, which means now I have to do what I did up here and I have to use a factor tree. So I'm looking for two numbers that multiply to 720. Now this one's pretty easy because that's 0, so I know it's 72 and 10. And I'm going to keep breaking down from there. So 72 is 9 times 8. 9 breaks down to 3 times 3. 8 breaks down to 4 and 2. And then 4 breaks down to 2 and 2. And then 10 breaks down to 2 and 5. So something that may be helpful, because we broke down a lot, is cross out the numbers that you broke down, because you're not going to use those anymore. So 72 is out, The 10 is out, the 9's out, the 8's out, and even that 4 is out because I broke it down. Okay, so now you're looking for pairs. I have a pair of 3s, a pair of 2s, and I have another pair of 2s with this leftover 5. So my pairs are going to come out, my leftovers are going to stay in. Okay, x equals -4 plus or minus. I'm just rewriting that part. So my pairs come out. 3 times 2 is 6. 6 times 2 is 12. And I have a leftover 5. All over 22. So you have to simplify that radical first. Okay, simplify the radical. So you're doing the quadratic formula just like we did last week. Simplify that radical, and then you're going to get solutions that look like this. At this point, remember, you are looking at the 3 outside terms, and you're determining which number goes into -4, 12, and 22. So the only number that goes into -4, 12, and 22 is going to be 2. 2 goes into all 3 of those. So 2 goes into -4, -2 times. 2 goes into 12, 6 times. 2 goes into 22, 11 times. Which means your final answer for this problem is x equals -2 plus or minus 6 square root of 5 all over 11. Okay, I know it's a lot of work, but again, it will always work for you. So if you didn't like factoring, or you don't like completing the square or taking square roots, this will always work as long as you go through and do it step by step. As soon as you start skipping steps, that's where you're going to run into issues. Okay, let's do one more. I'm going to give it to you. My recommendation would be to pause the video and try it and see how far you can get on your own, and then press play when you're ready to go. I'm going to do a brief pause, but I'm going to keep going. So your equation is 3x squared minus 12x plus 11 equals 0. So at this time, again, I would pause the video. And try it on your own. And then when you're ready, come back. All right, so you've tried it. Here we go. First things first, am I in standard form? So ax squared plus bx plus c, I am. I'm set equal to 0, so I'm good. My second step is going to be to identify my a, b, and c. So a is 3, b is -12, and c is 11. Okay. From there, I'm going to plug everything into my formula. So x equals, remember that negative is a part of your formula, and this time b is also negative. So I have the negative, and I'm plugging in b, which is -12. Plus or minus the square root of -12 squared minus 4 times a times c all over 2 times a. So plug everything in and then simplify. Okay, one step at a time. So x equals negative, and a negative becomes a positive 12 plus or minus the square root of -12 squared is a positive 144. -4 times 3 is -12. -12, okay, so -4 times 3 is -12. -12 times 11 is a -132. All over 6. Now, some people are plugging, like they're looking at this part here and plugging that into their calculator completely, and that's fine too. So you can do -4 times 3 times 11 if that's easier. And you're still getting that -132. What you want to be careful of that you don't do is take this -4 and multiply it by both of those terms. You just multiply straight across, okay? All right, let's keep going. So x equals 12 plus or minus the square root of 144 minus 132 gives me 12 all over 6. Take your 12 and see if you can simplify it. So we're going to break it down. Two numbers that multiply to 12 are, let's do 3 and 4. Doesn't matter, you can do 6 and 2. And then 4 breaks down to 2 and 2. And again, once you break something down, you're not going to use it anymore. So I have a pair of 2's and I have a leftover 3. The pair comes out, the leftovers stay in. So x equals 12 plus or minus. My only pair is a 2, so that's coming out. The leftovers stay in. All over 6. And you're looking for the outside 3 numbers. Okay, it has to be all 3. What number goes into 12, 2, and 6? And hopefully you determine that was 2. So 2 goes into 12 6 times. 2 goes into itself once. 2 goes into 6 3 times. Leaving me with x equals 6 plus or minus. Again, you can put the 1. You don't have to. I'm going to write it for now. So 1 square root of 3 all over 3. Now, a lot of you are going to want to simplify here, but again, your 3 outside numbers are 6, 1, and 3. 1 is as simplified as it can go, so you're not allowed to go any farther. I'm going to go one step farther and rewrite it without the 1 and just write the square root of 3 over 3. So 6 plus or minus the square root of 3 over 3. This is also an acceptable answer. You can leave that 1 if you want to. Okay, so nothing's changing. We're not doing the quadratic formula any different. The only difference is that you will have to simplify the radical and then simplify your final answer instead of getting a whole number or a fractional answer.